Hello everyone, this is Dr. Neeraj Kherwal. I'm working as Head of R&D at Layer1x. In our previous video, we have seen how we can send messages across EVM-compatible chains. Today, we are going to see how we can send the messages from Solana to an EVM-compatible chain and vice versa. So, as a part of this book, we are referring to our GitHub documentation. Build your first XCDP Solana to EVM contract and XCDP EVM to Solana contract. So let us have a quick overview of this GitHub page. So as a part of which, if you notice, we have categorized it into 4 steps. The first one is for major steps. The first one is basic steps. Second one is Solana to EVM integration. Third one is EVM to Solana integration. And the fourth one is Xtalk gateway contact address. So the one that we have in the basic steps, the first one is prerequisites, set up Solana project and set up EVM project, which means what? That these 3 steps, that is a basic step, is actually common to Solana to EVM integration as well as EVM to Solana integration. And Xtalk gateway contract address, as we know, they serve as the pathway for the communication across different chains. As a part of the basic step, we'll have to start with the prerequisites. So ensure that the prerequisites for Solana and L1x are installed on your machines. In case they are not, you can refer to the hyperlinks provided and get it installed. Similarly, for L1x, you can refer our previous video that we have, the first one in the L1x VM Smart Contract series, to set up the L1x environment, or else you can refer to this hyperlink that is provided and then follow the steps to install L1x. So once that is done, we'll start with setting up Solana project. So for this purpose, what I would do is, initially, I'll create a directory that would contain the programs related to Solana, Sepolia, as well as the L1x. So I'm naming it as Solana XCDP sold to EVM. We'll traverse to it and open it in code so that we'll have easy accessibility to the codes that we create. Now we'll initialize a new project. So create a directory for Solana. I name it as mkdir sol underscore XCDP. So this is done. Next step is to initialize a new anchor project. For this purpose, we are actually initializing the anchor project flow contract and copying it, paste it here. So once this is done, next step is to write your smart contract. We'll copy this smart contract and put it where? In programs, flow contract, source, lib.rs. So this is done. We'll go to the code. Here we have programs. In flow contract, we have programs, flow contract, source, and lib.rs. So we are replacing this default code with the code that we have on the GitHub. So this is done. Next step is to update the cargo terminal. We need to copy this and ensure that we are updating the cargo terminal which is inside programs flow contract. The reason for this is, if you notice, we have this cargo.toml outside as well. So we need to update this cargo.toml which is inside programs flow contract. So we'll replace this default one with the one that we have here. So this is done. Fourth step that we have here is to install the dependencies. So for this, we need to go to the Solana project that we created inside flow contact and then run these commands. I'll copy this. I'll go to the flow contact folder and then we'll run this command. So this is done. Next step is to compile the smart contract. So we'll copy this command to anchor build. So once this anchor build is done, then we can get the list of key pairs. So anchor build takes a bit of time. So anchor build is done. Next step that we have is to display the list of key pairs, for which we will copy this command. As a part of the output of this, we are actually expecting our Solana program ID. So we'll paste it here, run it. So this is the flow contract Solana program ID we get. We will copy this and save it here. So I've created a template for the ease of use because we are required to use it at various places as such. So this is done. Next, you need to declare program ID. So in this lib.rs, we need to update the program ID that now we have got. So for that purpose, we'll go to code, lib.rs, and you notice some declared program ID was already there. So the purpose is when you want to build it initially, you need to have some dummy value here. If you give some, say, variable name, your Solana program ID, it won't get compiled. So that is the reason we are required to give the dummy program ID initially. Now we are giving the Solana program ID that we received, right? So we'll save it. So this part is done. Next step is to configure the scripts. So for this purpose, we'll create a scripts folder and add this content onto the scripts folder. So what I would do is, I'll go here, inside this actually, programs flow, and I'll add the folder scripts. No, here we don't want to add. We want to add it inside flow contact. So I'll create it here. Yes, that is the proper position. Scripts. So this is okay. Now next I want to create the script. So I'll add a file. This is done. And now I'll copy this code of the script. Paste it here. This part is done. Now let us follow the guidelines that we have one by one. The first one that we have is to ensure that the connection is set to DevNet. So let us make sure. So yes, the connection is set to DevNet. Second step that we have is to load the wallet key pair path for the id.json file as your key pair path, in the sense this parameter. So I already have my key pair path, which I will replace it here. So here we'll start with your key pair path and replace with the one that I have for mine. Next step that we have is update the program ID with the Solana program ID. So this is the Solana program ID that we have. We'll replace it here. So this is done. Next, what we have is to update your ideal path. Where will you find it? You will find it in target ideal flow contact.json. So let us check it in the code. I need to go to target ideal, and this is the file for which I'll right click and copy the path. Go to the script initiate flow. your ideal path and replace it. So this is also done. I'll copy this keeper path for my further reference as well, which I will need at other places, in other scripts as well. Okay, this didn't get copied, I guess. Let us see. Okay, this entire has got copied. Just give me a moment. Okay, so this is done. Next, we are required to configure anchor.toml and copy it here. This is the existing default one, which I'll do is add it here. For this, now what I'm required to do is I need to give my flow contract. I need to give my Solana program ID. So Solana program ID, we have it here. We'll copy it, replace it. Similarly for keeper path, and copy it, add it here. So this is also done. Good. Next comes the 9th step, the critical one, because if you have done everything fine as of now, then you will be able to compile, deploy, and run the script to get the details that we are expecting here. So let us start with compiling the Solana program. We'll copy this, come to the terminals, and do anchor build again. Why are we doing anchor build again is we have updated the Solana program ID here. So yes, this has been done. Next step is to deploy the Solana program. Let us copy this command and try to deploy it. So once it's get deployed, then we can run the initiate flow script that we have. So the Solana contract has got deployed. Now next step is to run the Solana program. So let us copy and run it. Run the initiate flow script. So this is working. We have got the data account and transaction hash. We can simply copy this and save it for the future use. We might need it. Wait. So this is done. So at this stage, what we can say is our Solana project setup is done. Now we come to the third step, the major one, set up EVM project. Now for EVM project, we'll be using hardhat. So for this purpose, we'll have to initialize a new project, create a new directory. So let us do it. What I will do is, I'll come out of it. We are inside XCTB Sol EVM. I'll create a new directory, EVM XCTB. Traverse to it. So this part is done. Next we need to do is initialize a new NPM project. For this, we'll copy this command, paste it here. Got this is done. Next step is to install hardhat and set up the project. So for this, we'll first of all install hardhat, copy it. Once this is done, next step that we have is to set up the hardhat project. And in case we are actually, in this case, we'll copy it, let the hardhat get installed first. Okay, so this is done. Next command is to do npx hardhat will create a JavaScript project. Yes, install the dependencies related to it. So this is done. After that, we need to go for the installation of the necessary plugins and dependencies. So this is related to the hardhat toolbox. So let the hardhat project installation get complete first. So this is done. Now we'll go for hardhat toolbox. After which we will write the EVM smart contract. We will copy this smart contract that we have. Okay, so this is done. We'll go to the code, minimize this, go to EVM XCDP, contracts, log.sol. This is the default one, and replace it with the one that we have copied and rename this one to XCDP core. So this is done. Next step is related to the scripts and configurations. So this is the deployment script that we have. We'll copy it. Here we don't have scripts folder as such, so we can create one. And what I would do is I'll create a file, deploy.js, add it here. This is done. Hardhat configuration files, we'll copy it. This is hardhat configuration file default. I'll replace it with the one that we have. Now here you need to notice is you need to provide your private key or the inferior private key, whichever you are using. So in this case, we are using Sepolia as our destination, or this is, since this is a EVM contract, Sepolia is the network that we are referring to. So that is the reason I need to provide this system account private key, which is nothing but this. So here I'll be replacing the private key that I have for the Sepolia blockchain network. So I'll copy this and put it here. So this is done. Next step that we have is to deploy the contract. So I'll copy this, go here and try to deploy the contract. So yes, the contract is getting deployed on Sepolia. So once that is done, our EVM project would be set up. So yes, that is done. Very nice. We will copy this Sepolia contract address because it will serve as our destination contact address, isn't it? So this part is done. So as of now, we have covered this basic steps in its entirety. That is prerequisites, set up Solana project and set up EVM project. We are done with this part. So now we come on to Solana to EVM integration. So what we are required to do is, as of now, we have Solana as the source contract, Sepolia as the destination contract. Now we need to have L1x flow contract, which will serve as the medium for the communication between the two. So for this purpose, we'll have to create a new L1x project. So we'll copy this command. We'll come out of the EVM project. So this is okay. And paste this command. And what is the name I want to give? So I want to give the name, say, L1x XCDP, right? Following the same procedure which we had. So yes, this has been done. Next, what we need to do is we need to copy this smart contract and put it at source lib.rs. I'll copy it from here, go to the code, minimize this, go to L1x XCDP, source lib.rs. At this place, we have the default contract, which we are replacing with the one that we have in our Gitbook. So this is done. Next step that we have is to update cargo terminal file. So I'll copy it from here. Go to the cargo terminal. Replace the default one with this one. So this part is done. Now we go for cargo L1x build to compile the project. Okay, so we are getting some error, I guess. Let us check what is the issue. Okay, so the problem we have here is we haven't actually been to the project that we created. My mistake. We'll go to L1x XCDP and then we'll try to do cargo L1x build. So once this project is compiled, then what we'll have is, we will have this object file created, which we will use for further steps. Okay, so the smart contract has got compiled. We have got this object file created. Next step that we have is to go for deployment. And as we have seen in our previous L1x smart contracts video, that to deploy any L1x smart contract, we need to have a wallet with some faucets in it. So if you don't have a wallet, you can create one and get some faucets from the testnet faucet. If you already have a wallet, import it. So what I'm going to do is, I'm going to import the wallet that I already have. I'll copy this command. I'll replace the private key with the private key that I have for the L1x wallet. So those who have seen our previous videos would be familiar with Super, Emma, Evan, Bobby, right? Anyways, we are copying the private key of Super, adding it here and importing the key. So yes, this is done. Nice. Now we can go for deployment. So we'll copy this command, put it here, and as we are using testnet v2 itself, we don't need to replace it. I'll remove this angular brackets. Angular brackets are just for the purpose that you update the endpoint with respect to the network that you are using. And to deploy, I'll specify the path, target, L1x, release, and the file name that we have, that is L1x cdp.o. So just to show you to the audience that how we have got this object file path. If someone is new to it, we have this target folder. Here we have L1x first, inside which we have release, and this is the file name. So yes, I need to replace it with this one which has been created, L1x Sol EVM XCDP. So I'll replace it with the same name, L1x Sol EVM XCDP. So this is okay. And now I'll try to deploy it. So once this is deployed, next step is to initialize the smart contract. For this purpose, I'll copy the command. Okay, it's still getting deployed. Okay, now we'll initialize it. Again, for initialization purpose, we need to remove this angular brackets as we are not required to replace the endpoint. Sorry. And then we need to just give this deployed contact address here. So this will initialize the L1X flow contact. Yes, this has been done. The next step is to register the Solana contract and Xtalk flow contact with Xtalk node. So for this purpose, what are the things that we are required to specify? We need to have the source registry instance address. So this source registry instance address is nothing but the one that we have already provided in the example. And then we have the destination contact address, that is nothing but your flow contact address. Okay. Next comes source contact address, which is nothing but your Solana program ID. Source chain is Solana in this case, and events is null for Solana. And we are specifying the endpoint as V2 testnet and specifying the tree limit as well. So I'll simply copy this command and replace the details or parameters that we have. So as the practice we are following, we'll start with the start of the command so that we don't miss out on updating any of these. So L1X CLI beta contact call, this is the source registry instance address. We don't need to replace it, right? Register new source is the name of the method that we are calling, and the arguments that we need to pass. The first one is destination contact address. And as we had seen in our previous video related to EVM to EVM XCDP, even in this case, this destination contact address is your Xtalk node, because from Solana, your message will be going to L1X Xtalk node, and from Xtalk node, it will go to the destination, which is Sepolia network. So during registration, in the destination contact address, you need to specify the L1X flow contact initialized address. So I'll delete the one that we have in the sample here. And we have to save this from the terminal. Okay, so this is the initialized contact address that we have got. Okay, I'll first save it here, and then I'll add it here as well. Okay, so this is done. Now source contact address is nothing but your Solana program ID. So we'll copy it from here, add it here. Source chain is Solana, event filters is null, endpoint is set. So yes, we can register it to the source registry. Now once that is done, we come to the next step, implementing script to emit event from Solana to EVM. So here we are required to add scripts to emit event. So in your Solana project, you need to do this. First of all, I'll copy this emit event script. Go to Solana XCDP. Here I need to go to scripts. I have initiate flow, right? I'll add one more file with the name emit_event. Yes, this is done. And I'll paste the code here. Here what we need to do is, first of all, we need to update the wallet keeper path. So we have the wallet keeper path. Yes, I'll copy it. There we need to update here your keeper path. So this is done. Next, the arguments that we are passing to the emit event. So message is hello world, destination is Sepolia, and your EVM contact address. So let us get our EVM contact address, which is this one, and copy it. Go to the code. We have hello world message, Sepolia, and the EVM contact address is replaced with this one. So say hello world, I'm saying Solana to Sepolia. Right? So we are able to distinctly identify the message. So this part is done. Good. Now we need to update script path in the anchor.toml. So this is the new line which is getting added. I'll simply copy it. Go to the anchor.toml. At the end, I'll add it. So this is also done. Now the last and final step is to send the message from Solana to EVM. So for this purpose, we'll have to run this Emit event script. So this is our Emit event, which we were sending hello world Solana to Sepolia. So let us update this so that we know that this is a unique message that we have sent and we are able to receive. So say I'll say testing Solana to Sepolia XCDP. Okay, save it. Now to run this command, I actually need to run it from where? From the Solana project flow contract. Yes, so this is the place for it. I'll copy this. Paste it here and emit the event. So the transaction is triggered. I'll copy this transaction hash, which is the transaction hash of the Solana network. Go here, check for Solana DevNet Explorer. This is the one. So I'll just paste the transaction hash. So if you notice, we are able to see the details, right, related to it. We can see this unknown program details. We can copy this program data and use base 64 decode just to check what message has been sent. Is it the one that we were looking for? Okay, so it shows testing Solana to Sepolia XCDP, which means this has been sent. Now, if you want to check this transaction on Sepolia, that is a destination network, then in that case, we'll be required to check using the Xtalk gateway for Sepolia. Because if you remember, on the destination network, that is a Sepolia network, the transaction is triggered by the Xtalk gateway. So we'll go to the table, copy this, go to Sepolia testnet explorer. Since this is the gateway contact address, many messages would have been triggered by different programs as such. So that is the reason. Let us check, is this the one that we triggered? So we'll click to show more and view the input. So if you notice, we are able to see testing Solana to Sepolia XCDP. So yes, our destination network has received the message from Solana successfully. So this is the way we can actually pass the messages from Solana to any EVM compatible chain, and we can validate it as well. So thank you for watching this video and keep developing smart contracts. Happy coding. Take care. Bye.